So welcome to my presentation. This presentation is about cols4all. Cols4all is a tool, a dashboard, that is used to analyze color palettes. So rather than providing color palettes or generating color palettes, we let users analyze their own color palettes from popular, as we call, series like Color Brewer, CartoDB, etc. So we distinguish the palette type, categorical, so we have sequential, diverging, and bivariate. So a couple of subtypes. This is a little bit outside of the scope because it's in development, but you can experiment with it. So the whole tool is in development. However, it's already an open source R package. So it's published on CRAN as an R package. For those who are not familiar to R, on the GitHub page, this one, there's a description how to install the package. So you just have to run a couple of lines and to start the graphical user interface. If your institute has a Shiny server, then it's also possible to deploy it there so that you can use it. So the tool, so the main page of this tool contains a table. There's this one, so you see the palettes over here. So for instance, Brewer accent. It's a color palette. It has maximum 7 colors, and you see a couple of properties. So where palettes are colorblind friendly, if there are any colors that are very vivid, very saturated. So some classes means there is at least one color which is very saturated. If there's snowflake, means there are none colors that are very saturated. It's more like a pastel color palette. Then we have a property called fairness. Fairness means whether all colors stand out about equally. So in data visualization, if you have a bar chart and you have color for each bar, you don't want that one bar is more stand out more than others. So for instance, this palette, so the palettes with a cross, it means that they're not very fair, and with hard, then the colors are stand out about equally. For all these properties, I have applied a 3 scale. So either yes, no, or neutral. The parameters can be adjusted within the R package. So it's work in development, work in progress. So feel free to share your opinions. So for colorblind friendliness, we can sort, for instance, the palettes by colorblind friendliness to see what happens. So we see that for 7 colors, only 8 palettes are colorblind friendly. And so when you're looking for a palette, qualitative palette with 7 colors, 8 colors, 7 colors in this case, then best to look for one of these, and then you can see which one you like best, depending on the application at hand. So we look at contrast. So whether the colors are where there's low contrast between any 2 colors. If that's the case, then you need borderlines to separate them. I'll come back to that in a second. So first, colorblind friendliness. So for instance, a palette that's not colorblind friendly is a Tableau Classic 10. So let's dive into that. So Tableau Classic 10. This is just for the first 7 colors. You see, these are the colors, how they are perceived by people with normal color vision. So this is the Scilab color space triangle, where the lines indicate the hue. However, for people with color vision deficiency, they can't distinguish the hues as good as people with normal color vision. So these are called confusion lines. So confusion lines mean that all colors along a certain line are perceived with the same hue. So for instance, blue and red are perceived as blue and whatever you call it. But they can distinguish quite well. So this is how people with how the deutans would perceive these two colors, but they can distinguish it well. The triangle, so again I've used a couple of categories to make decision making a little bit easier. Behind that there are similarity, like distance measures between any two colors. So for instance, these red and green are perceived very well by people with normal color vision. However, a triangle means very similar. So indeed, depending on the screen that you're using, but my screen, it's possible to distinguish them. It's hard. The squares are even harder. So it's orange and green. They're quite very similar. I can't tell them apart here. So that's a really severe problem. Whereas if you look at palettes that score very well, like this Okabe, go to, where is it? This Okabe, so there's the similarity matrix. So there are no problems at all. So this is really one of the good, the better palettes in terms of colorblind friendliness. Then the next tab is HDL analysis. So HDL stands for hue, chroma, luminance color space. So this is just the pie. For primary colors, the chroma saturation can be increased. So this is actually a subset. But again, we can plot the colors along this, what I call hue necklace, and also have like scatter plot luminance chroma to see whether colors stand out about equally, so the fairness. So if we look at palettes that don't score very well on fairness, say tall muted, it's also a very good palette in terms of colorblind friendliness. However, it's not very fair. Let's see why. Muted this one. So again, the colorblind friendliness, it's very well. So no issues there. If you look at hue chroma, the chroma luminance, see that they are saturated about equally. However, the luminance varies a lot. So if you use say a white background, then the dark colors will stand out more than the brighter colors. So that's like I would say a minor issue. Then we look at contrast. So this is the contrast ratio. So this is a choropleth and a visual illusion. And you see that the colors can be distinguished quite well. However, if you look at the black square, there's this one, although they have very different hues, the blue and the yellow, you can distinguish them. However, the border is a little bit fuzzy. So we can solve that using border lines with high contrast, so either black or white. Black is better, I guess. So you see also the contrast with black and white. I use the open symbols for text, meaning that the open square has a contrast ratio which is sufficient for a AAA certificate. So it's also good for people with visual impairment. There's 3D blues, that's another thing. If you have dark, so I have also the dark mode. If you use blue that is, so let me check the original colors. If you have a blue that is pure blue, so pure primary color blue, against a black background with another color, then most people perceive a depth effect, and I think about the majority would perceive blue as being further in the background and red being in front. However, there are also many people who perceive the opposite. So it's something to take aware of. So if there's indication 3D blues, then it means that there are color palettes with pure blues. So this is the application. You can play around with either choropleth or dot maps, text plots. So, well, that's it. Thank you.